கனெக்ட் ஸ்க்ரீன் ரெக்கார்டிங் பண்ண முடியும் கேளுங்க கொஞ்சம்.
கேளு, நீயே கேளு. Okay. Sushil, you have started recording. Then pause it. Will wait for 2 to 3 minutes. Is it okay? Shall we start or? Shinde?
Yes, sir.
Okay. So somebody recording, right? See, without recording, I am not doing. Okay, have you started? Okay. So, okay, good morning, everybody. So today, we will see how to do sonic underexpanded jet. Okay. So the same thing, the same. So as we discussed for subsonic, I think the dimensions are same. Okay. Dimensions are same, and I want you to see the paper first. The paper is about coaxial jet. One minute, wait, ma. Ma, only 15 minutes, ma. Shinde. Shinde. Shinde, we will finish within 15 minutes, 10 to 15 minutes maximum. Clear? Okay. See, okay, shall we start again? Don't mind me. Can we start again? Okay. Okay, we'll start now. Okay, this is the paper. You can get the paper. I will share you the paper in the WhatsApp or something. So I'll just first show the nozzle. So this is the nozzle. Okay, this is the nozzle. Okay, you can see my nozzle. So this is the nozzle. Okay, you can see the inlet diameter is 30.4. Actually, this is a coaxial nozzle, but as of now, we are going to do only single nozzle. Okay, so 30.4 inlet diameter, exit diameter is 11.6. You can see my cursor, and then the nozzle length is 35.5, and yes, that's all. So inlet dia 30.4, all dimensions are in mm. Inlet dia 30.4, exit dia 11.6, nozzle length is 35.5. So the idea is that first you open, okay, you go to any drive, you open a new folder called, you rename the folder as lower Raju Underexpanded. Lower Raju single jet underexpanded. Okay, I'm creating a folder like this. So this folder, so as soon as you open the Gambit console, you go to browse, you go to that folder, D drive, I think Naren, and then Chu. Yeah. It is better to do like this. First create a folder and start a session. So if you give run, your Gambit will open. Okay, and then okay, this is the blank screen. I think you all know this. So this is the blank screen, and you can see it is showing as default ID. Okay, so as usual, first make it diamond pointer. This is normal pointer, ma. You can see this is normal pointer, and if you just right click and left click, you do right click and left click in your mouse, it will become diamond pointer. It will become diamond pointer. It will look like a diamond. Okay. So first mark a point at 0,0. Okay, that will be your nozzle exit, and exit diameter is 11.6. So I am marking a point at 5.8. Okay, and then this will be the nozzle exit. So nozzle length will be 35.5. So X, I am drawing nozzle in the negative direction, 35 minus 35.5. Okay. So you just fit in the screen. This option is called fit to window. Okay. You can see my cursor. In the description, it is shown fit to window. Okay. So you can see nozzle exit, nozzle inlet, and the nozzle inlet. Nozzle inlet is 30.4. So half of that will be 15.5. Why I am doing half is that 15.2. Okay. Why I am doing half? Because I am doing axisymmetric. Okay. So, and then we plot the other points 0, 100. You plot a point. And please mind that this is underexpanded. So I'm not doing 400 mm domain. I am doing only 300 mm domain. So this will be 300. 300. You plot a point there at 5.8. Okay. And then you plot a point at 0. And 300, 100, 300, 5.8, 300, 0. Okay. So before zooming out, we'll start drawing the lines, that is edges. So always draw from left to right. Left to right. You can see I am I am choosing this left point and right point. I am clicking right click in the mouse. So you will get a line. Okay, again top point, bottom point. You must select using left click. For selecting left click, and then if you click right click, you will get the point. And then zoom out. I think that point I didn't keep 300,0 I didn't keep. Yes, just now I kept it. You go to edges. I'm doing the edges. Edges means lines. Okay, from top point to bottom point. Selecting using left mouse, left click, and then drawing the line. Again, left click, right click. Again, left click. You select the points and then right click. Again, left to right. So this is my way of doing. You can try your own ways, but at the beginning you can try my way. So at the edges, instead of selecting, you can select like this also. You select all the edges, make it as a face. Okay, space means surface. Edge means line. Okay, after making the face, it will become like a blue color, some parrot green or blue. Okay, now go to mesh edges. Okay, the only thing is that you have to very careful in meshing this one and this one. Okay, it should be same. You just select interval count to showing 6. So you have to double it, 12. Okay. See here, mesh edges. I am doing mesh edges for the domain nozzle and nozzle inlet and domain exit at that particular nozzle inlet. Okay, so it is default, it was 6, so I am making it 12. Do right click, it will be edge mesh will come. Similarly, this line and this line, generally it is 36. You can make it 72. So make it as a edge. And here it is 300. Here also it is 300. Make it 600. So you have to understand I am doing a very fine mesh. Okay, so under this one is 94. 94 into 2 will be 180, 188. 188. Okay, so I have meshed all the edges with the interval size 0.5. Interval count is double. Okay. Okay, just to select the face, give mesh, it will be meshing. You can see it is a very uniform, nice mesh. Okay. I'm zooming out just to show you it is very nice mesh. Okay. Nicely, closely spaced mesh. Okay. So to drag and all, you have to use a regular pointer, not the diamond pointer. Diamond pointer is just for selecting. Now the third step is to assign the boundary conditions. So go to boundary condition. First wall, default it will be wall. So you select this fellow and this fellow, and just to put right click, it will become wall. And then select pressure inlet. You select this one. This is the inlet. Okay. So you just right click, it will become pressure inlet. Then you click here. You need axis. So axis is the second option. So you click this one and this one, it will become axis. Now finally pressure outlet. This one you select pressure outlet in the drop down box and then select the top of the domain and the right edge of the edges of the domain. It will become pressure outlet. And finally go to the zones, specify continuum types. So select the face and then just right click so you are mentioning that the fluid is going inside the domain and nozzle. Okay, over, my work is over. It's very simple. So again go to file, save as. I have not saved this section. So you do file, save as. So dialog box will open. So you give lower arrow lower Raju, single jet, NPR, say underexpanded. So as soon as you give accept, you can see in the transcript, it has been saved. And then you have to export. So you have created the mesh, you have to export the mesh to the Fluent. Okay, file, export, mesh. So export as 2D mesh. Accept, give accept. So you can see here in the transcript, mesh was successfully written to lower Raju single jet underexpanded dot mesh. Okay. So my gambit part is over. Okay. Now in here, you can see I will open Fluent. I'll just file read mesh. So I have already opened something. So you have to discard everything. You continue newly. So, okay, lower Raju single jet underexpanded dot msh. You open this. Okay. So you will get warning as usual. You go to general. First scale it in mm. You can just give scale and close. You check the grid. You can see it is done. Okay, it is done. It is done. Done means yes, the grid is good. And the solver type is density based. Velocity formulation is absolute. Time is steady. 2D space is not planar. We have to give axisymmetric. Clear? And then yes. And then units, like you change it to pressure. Pressure you change it to default. It will be Pascal. You change it to ATM. I have changed it already to ATM, so no issue. Then go to models. These are the turbulence models. In that the energy is off. First make the energy on, and then viscous it is laminar default. I will select one equation Spala-Talmaras model, which is very successful model in my past. Okay, so I am using Spala-Talmaras model, and then go to materials, select density. It will be air. Air, the density is 1.225. You can change it to ideal gas. Okay, change, create, and close, and then go to boundary condition, and you specify the boundary condition of the pressure inlet alone. Others, no issue. So you have been asked gauge total pressure. Okay. So we will do for say NPR 3. Okay. For starting NPR 3. NPR 3 means it is absolute pressure 3. So gauge pressure I will give 2. Okay. Gauge pressure I will give 2. Click OK. And then go to, yes, go to methods. Methods you can see implicit, explicit, implicit, leave it as it is. Solution methods, formulation, implicit, explicit. We are using implicit, it is default. And then flow is upwind, turbulent viscosity upwind. Leave it. I'm not changing anything there. Important thing is solution control Coran numbers, you have to change. See, if you give 5 as Coran number, default it will be 5. I'm changing to 0.5. Okay. So, because 5 means it will diverge completely, it will diverge. So you give 0.5 initially, and then go to monitors. You can see residual monitors. It is all default, it is 0.001. It is okay now, giving 0.001. So initialize the solution, go to default, it will be hybrid, select standard, and then give pressure inlet. You will get some velocity around 400. That is fine. Initialize. So initialize, done. So run calculation, finally give run calculation. So just number of iteration, you just add some number of iteration. Say first initially I'm giving 10,000 iteration. Okay. So we will see, you give calculate. So it will start calculating. You can see this is the y-axis. You can see the iteration. The x-axis is the error. Okay, x-axis is the error. So it is started calculating. So this will take time to complete. So let us wait for the iteration to complete. So to summarize this session, we started with the gambit. I will just again go to the gambit. Yes, this is the gambit. We started with the gambit. We have first modeled, meshed, and assigned the boundary conditions. And finally, we exported to Fluent, and then we gave the setup, or we made the setup. So in CFD, the terminologies are, these are called pre-processing terms. So modeling, meshing, assigning boundary condition, and then exporting it to Fluent, assigning, giving the setup, initializing the run, and then starting running is called pre-processing. Now this is calculating the solution. So this is called processing. It is under processing. So we have to wait for the processing. Roughly it will take 15 minutes to say 30 minutes. It depends on the Quran number. So we will wait for the solution to get solved. So our ultimate aim is that these curves are there, no, this green curve, this blue curve. That is, we are solving. You can see continuity, x velocity, y velocity, energy, and nut is the SA model. So all the curves should come below this 10 power minus 3. Okay, that means the solution is converged, and after that we can do post processing. So that will be again an interesting session. So we have to wait for the solution to get converged. Clear? This session, I am closing this session. So we will wait for the convergence and then again start some other session, maybe 1 hour later, or 11:30, 11:45. Okay, is that okay? Thank you for this session. And Shinde, you can stop the recording.